The year is 1943, and somewhere in the rolling hills of Normandy, a German Tiger tank commander sits in his steel fortress, watching through his periscope as American Sherman tanks advance across an open field. He smiles. His 88mm gun can penetrate the Sherman's armor from over a mile away, while the American 75mm gun struggles to scratch his Tiger's thick frontal plate. In the coming engagement, he will destroy 3, perhaps 4 of these American machines before they even get close enough to pose a threat. He has heard the stories from the Eastern Front, seen the after-action reports from North Africa. The Americans, it seems, have brought a knife to a gunfight. But here is what that German commander does not yet understand. Here is what the entire German High Command, with all its tactical brilliance and technological superiority, has failed to grasp. For every Tiger tank that Germany produces in their increasingly bombed-out factories, America is building 50 Shermans. For every Panther that rolls off the assembly lines in Kassel, 100 Shermans are being loaded onto ships in Detroit, Chicago, and Cleveland. The Germans have built the better tank, yes, but the Americans have built something far more important. They have built a weapon that can be manufactured, shipped, maintained, and replaced faster than the enemy can destroy them. They have built not just a tank, but an entire system of warfare that will bury the Third Reich under an avalanche of steel. This is the story of how America's most criticized, most ridiculed, and most underestimated tank became the weapon that rolled across Europe and crushed Hitler's war machine. This is the story of the M4 Sherman. To understand the Sherman, we must first understand the world that created it. In the spring of 1940, as German tanks race across France and the Low Countries, the United States Army possesses exactly 328 tanks of dubious quality. The American Tank Corps is a backwater of military planning, underfunded and largely ignored since the end of the First World War. While Germany has spent the entire 1930s developing its panzer divisions into a sophisticated combined arms force, America has been content to let its armored forces atrophy. The few tanks in American service are relics, machines designed for the static warfare of the Western Front rather than the lightning-fast maneuver warfare that is about to define the Second World War. The fall of France changes everything. Suddenly, American military planners watch in horror as German armor tears through what was supposed to be the finest army in Europe. The Maginot Line is bypassed, Belgium is overrun, and the British Expeditionary Force barely escapes from the beaches of Dunkirk. In a matter of 6 weeks, the military calculus of the entire world has shifted. Tank warfare is no longer a theoretical concept, debated, in staff colleges. It is the dominant form of warfare, and America is hopelessly, dangerously behind. The U.S. Army issues an urgent requirement. They need a medium tank, something that can stand up to German panzers while being reliable enough for the rigors of modern warfare. They need it fast, and they need it in enormous quantities. The initial result is the M3 Lee, a stopgap design that mounts a 75mm gun in a hull sponson with a smaller 37mm gun in a turret on top. The M3 is awkward, tall, and tactically limited by its hull-mounted main gun, but it serves a crucial purpose. It gets American industry thinking about tanks, building tanks, solving the thousands of engineering and manufacturing challenges that come with producing armored vehicles at scale. But even as the first M3s are rolling off the production lines in early 1942, American engineers are already working on its replacement. They take the basic chassis, drivetrain of the M3, and redesign everything above the hull floor. Gone is the awkward multi-turret arrangement. In its place sits a single, fully rotating turret mounting a 75mm gun. The design is clean, simple, and built from the ground up for mass production. In April of 1942, the U.S. Army standardizes the design as the medium tank M4. The workers at the Lima Locomotive Works in Ohio give it a simpler name. They call it the Sherman, after the Civil War general who pioneered total war. The Sherman that emerges from those first production lines is a revolution in military engineering, though not in the way most people think. It is not revolutionary because of its armor, which at 50 millimeters on the frontal arc is adequate but not exceptional. It is not revolutionary because of its gun, which is effective against most German tanks in 1942, but will struggle against the heavier armor that Germany will field later in the war. The Dome.Cos. Sherman is revolutionary because it represents a fundamental shift in how America approaches industrial warfare. Look at the engine. While German tanks are powered by specialized, high-performance engines that require skilled machinists and rare materials to build, the Sherman uses engines that are already in mass production for other purposes. Some Shermans use the Continental Radial Aircraft engine, others use twin General Motors diesel engines. Some use a Chrysler multibank engine that is essentially 5 truck engines arranged in a star pattern around a common crankshaft. The diversity of power plants means that production is never bottlenecked by a shortage of any single engine type. If Continental cannot deliver enough radials, Chrysler can pick up the slack with multibanks. It is not elegant, but it works. Look at the transmission. German tanks use sophisticated manual transmissions that require extensive training to operate effectively. The Sherman uses an automatic transmission adapted from truck and bus designs. A tank crew can train a new driver in days rather than weeks. When a transmission fails in the field, it can be swapped out and replaced in hours rather than having the tank shipped back to a depot. Again, it is not the most advanced solution, but it is the most practical one. Look at the tracks. German tanks use overlapping road wheel designs that provide excellent weight distribution and a smooth ride, but are nightmares to maintain in the field. If an inner road wheel is damaged, the entire track assembly must be disassembled to replace it. The Sherman uses a simple bogie suspension with vertical volute springs. It is rougher riding than the German system, but any mechanic can replace a bogie assembly with basic tools in under an hour. In the mud and snow of a European winter, when German tank crews are spending hours chipping ice from between their road wheels just to move their vehicles, Sherman crews are simply driving. This is the genius of the Sherman. It is not designed to be the best tank on the battlefield. It is designed to be the best tank for the reality of global industrial warfare. Every design decision prioritizes reliability, maintainability, and manufacturability over raw performance. The Sherman is a tank designed not by warriors dreaming of glory, but by engineers who understand logistics, supply chains, and the brutal arithmetic of attrition warfare. And America builds them by the tens of thousands. The factories in Detroit retool from automobiles to tanks. The shipyards in California add tank production to their roster. Even the locomotive works in the Midwest. Companies that have never built anything more complex than a steam engine are soon turning out Shermans at a rate of hundreds per month. The production numbers are staggering. In 1942, American factories produce over 10,000 medium tanks, most of them Shermans. In 1943, they produce nearly 20,000. By the end of the war, American industry will have produced just under 50,000 Sherman tanks in all their variants. To put that in perspective, Germany will produce approximately 6,000 Panther tanks during the entire war. They will build fewer than 1,400 Tiger tanks. The Soviet Union, with its massive T-34 production, will build more tanks than Germany, but even Soviet production struggles to match the sheer scale of American output. The United States is outbuilding everyone, and the Sherman is the centerpiece of that industrial miracle. But raw numbers mean nothing if the weapons cannot reach the battlefield, and here again the Sherman demonstrates its genius. The tank is designed from the outset to fit within the constraints of ship-based transportation. Its width is limited to ensure it can pass through the loading doors of standard Liberty ships. Its weight is kept under 35 tons, light enough that it can be loaded and unloaded using shipboard cranes. When Shermans arrive in Britain, North Africa, or the Pacific Islands, they can be driven off the ships, fueled, armed, and sent into combat within hours. German tanks, heavier and more complex, often require special heavy-lift equipment and extensive preparation before they are combat-ready after transport. The first Shermans see combat in October of 1942 during the Battle of El Alamein in North Africa. British and American forces, equipped with hundreds of the new American tanks, face off against Rommel's Afrika Korps. The Shermans perform well. Their 75mm guns are effective against the Panzer EIs and IVs that make up the bulk of German armour in theatre. Their reliability in the desert conditions surprises everyone. Where British tanks break down in the sand and heat, the Shermans keep running. Where German tanks struggle with fuel supply in the vast North African distances, the Shermans' relatively fuel-efficient engines keep moving. Montgomery's victory at El Alamein is built on many factors, but the reliability and availability of Sherman tanks is among them. Then comes Sicily in July of 1943, and Italy in September. American and British Shermans support the invasions, providing crucial mobile firepower as Allied forces fight their way up the Italian peninsula. The mountainous terrain of Italy is not ideal tank country, but the Sherman proves adaptable. Its relatively compact size allows it to navigate the narrow Italian roads and villages. Its reliable mechanical systems mean that tanks can keep up with infantry advances even over difficult terrain. Italian and German defenders discover that while they might destroy individual Shermans, there are always more coming up behind them. But the real test comes on June 6, 1944, D-Day. The beaches of Normandy. The invasion of France represents the largest amphibious assault in history, and armour is central to the plan. Shermans are modified with waterproofing and extended air intakes, allowing them to wade through several feet of water. Some are equipped with flails to detonate mines. Others carry fascines, large bundles of wood that can be dropped into trenches to create crossings. Still others mount flamethrowers or demolition charges. The Sherman's simple, modular design makes it an ideal platform for these specialized variants. Where a more complex tank would require months of engineering work to modify, Sherman variants can be produced in weeks. The Shermans that land on Omaha and Utah beaches face a baptism of fire. German artillery and anti-tank guns concealed in the coastal fortifications take a heavy toll. Tanks are hit and set ablaze. Crews bail out under withering machine gun fire. The Allied advance teeters on the edge of disaster. But the Shermans keep coming. For every tank destroyed on the beach, 3 more are being unloaded from landing ships. For every crew lost, another is ready to take their place. The Germans are fighting what amounts to a defensive battle of attrition against an enemy with infinite reinforcements. It is a battle they cannot win. In the weeks following D-Day, as Allied forces push into the Norman Bocage country, the limitations of the Sherman become apparent. The hedgerow country of Normandy is a defender's paradise, every field bounded by ancient earth berms topped with thick vegetation. German anti-tank guns hide in the hedgerows, able to engage Allied armour at point-blank range while remaining nearly invisible. German tank destroyers and the first Panther tanks begin appearing in numbers. The Panther, with its sloped armour and powerful 75mm high-velocity gun, badly outmatches the Sherman in direct combat. A Panther can kill a Sherman from the front at ranges where the Sherman's gun cannot penetrate the German tank's armour. This is when the myth begins, the myth that will haunt the Sherman's reputation for decades. American tank crews start calling their vehicles Romsons, after the cigarette lighter company whose advertising slogan is, "Lights first time, every time." The Sherman, they say. Lights first time, every time. The stories spread. 5 Shermans to kill 1 Panther, 4 Shermans to kill 1 Tiger. The numbers vary, but the message is always the same. American tanks are death traps, and American tankers are being sacrificed wholesale against superior German armour. But here is the truth that gets lost in those stories. Yes, the Panther is a better tank than the Sherman in a one-on-one fight. Yes, the Tiger's 88mm gun can destroy a Sherman before the American tank can get close enough to fight back. But wars are not won by one-on-one fights. They are won by armies, by logistics, by the ability to maintain pressure on the enemy day after day, week after week, until the enemy cracks. For every Panther that destroys 3 Shermans, there are 5 more Shermans ready to continue the advance. For every Tiger that ambushes an American column, there are American tank destroyers, fighter bombers, and artillery ready to respond. The Germans are fighting a war where every tank lost is a disaster because there are no replacements. The Americans are fighting a war where every tank lost is a statistic because 5 more will arrive next week. It is not heroic, and it is not fair to the men in those tanks, but it is effective, and the Sherman is more adaptable than the German tankers expect. When the hedgerows prove too difficult to penetrate, American sergeants weld steel teeth cut from German beach obstacles onto the fronts of their tanks, creating impromptu plows that can tear through the hedgerows. When the 75mm gun proves inadequate against heavy German armour, American factories retool to produce Shermans mounting British 17-pounder guns, creating the Sherman Firefly. When tankers complain about the Sherman's tendency to catch fire when penetrated, modifications are made to store ammunition in wet stowage bins surrounded by water jackets, dramatically reducing the rate of catastrophic fires. The Sherman evolves. Where German tanks are produced in a bewildering array of variants, each requiring different spare parts, different ammunition, different training, the Sherman maintains a common chassis across most variants. A mechanic trained on an early model Sherman can service a late-war Sherman Firefly with minimal additional instruction. Parts are interchangeable. Logistics are simplified. The entire system is designed for sustainability over the long term, and by the summer of 1944, the war has become all about the long term. As Allied forces break out of Normandy in late July and early August of 1944, the nature of the war changes. The static fighting of the bocage gives way to mobile warfare, the kind of rapid advances across open country that favours the side with reliable, available armour. The Germans discover that while their Panthers and Tigers might win individual engagements, they cannot be everywhere at once. American Shermans, supported by overwhelming air superiority and artillery, begin to simply flow around German strongpoints. Where the Germans concentrate their armour to block one advance, 3 other American columns push forward elsewhere. The Germans are trying to plug a dam that is breaking in a dozen places at once, and they do not have enough tanks to cover all the gaps. Paris falls in late August. By September, Allied forces are racing across France faster than their supply lines can keep up. The advance is limited not by German resistance, but by fuel shortages. Every Sherman tank, every truck, every jeep requires gasoline, and all of that gasoline must be transported from the Normandy beaches across hundreds of miles of liberated France. The Red Ball Express, a massive convoy system using thousands of trucks and drivers, keeps the fuel flowing. It is yet another example of American logistics triumphing over tactical challenges. The Germans have better tanks, but America has better supply chains. Then comes the fall and winter of 1944, and the war bogs down along Germany's western border. The Germans, fighting now on their home soil with shortened supply lines, mount increasingly desperate resistance. In the Hürtgen forest, American armour struggles through dense woods against determined German defenders. In the industrial cities of Aachen and Metz, street fighting negates many of the Sherman's advantages. The advance slows. German commanders begin to believe they might yet stabilise the front, buy time for their wonder weapons to enter production, perhaps force a negotiated peace. In mid-December, Germany launches its last great offensive in the west. The Battle of the Bulge crashes into the American lines in the Ardennes forest, aiming to split the Allied armies and capture the vital port of Antwerp. German planners have assembled their last mobile reserves, including substantial numbers of Panthers and Tigers. They achieve complete surprise, and for a few desperate days, it appears the offensive might succeed. But look at what happens. American forces, caught off guard and forced back, do not break. Individual units surrounded in towns like Bastogne hold out against overwhelming odds. Reinforcements rush to the threatened sector, and among those reinforcements are hundreds of Sherman tanks. The American response to the German offensive is not clever tactical maneuvering. It is simply overwhelming force. Entire armoured divisions are moved hundreds of miles in a matter of days. Fresh Sherman tanks replace losses faster than the Germans can inflict them. Within 2 weeks, the German offensive has stalled. Within a month, it has been completely reversed. The Battle of the Bulge is the last time that Germany can concentrate enough armor for a major offensive, and even then, the offensive fails in large part because the Americans can absorb losses that would cripple any other army. The Germans destroy hundreds of Shermans during the battle. They also destroy their own last mobile reserves. When the spring of 1945 arrives, Germany has virtually no operational armor left. America is still shipping Shermans across the Atlantic by the thousands. The final drive into Germany in early 1945 is less a battle than a procession. German forces, starved of fuel, ammunition, and hope, mount scattered resistance but cannot stop the advancing tide. American Shermans race across Germany, sometimes covering 50 or 60 miles in a single day. They reach the Rhine in early March. They cross the river on temporary bridges, even as German defenders try to destroy the crossings. They link up with Soviet forces advancing from the east in late April. Berlin falls in early May. Germany surrenders on May 8, 1945. In the European theatre alone, the United States has employed over 20,000 Sherman tanks. Thousands more have been supplied to British, Soviet, and Free French forces under Lend-Lease. The Sherman has fought from the deserts of North Africa to the streets of Berlin, from the beaches of Normandy to the forests of the Ardennes. It has served as a gun tank, a tank destroyer, a recovery vehicle, a flamethrower, a mine clearer, and a dozen other specialized roles. It has been criticized, ridiculed, and mourned by the men who fought in it. It has also won the war. But the Sherman story does not end in Europe. While the war in the West winds down, the war against Japan continues, and here the Sherman proves its worth in an entirely different kind of combat. The Pacific War is not about sweeping tank battles across open plains. It is about jungle fighting, island assaults, and close-quarters combat against fanatical defenders. Japanese tanks are universally inferior to the Sherman in firepower, armor, and reliability. The real challenge in the Pacific is terrain. On islands like Saipan, Guam, and Iwo Jima, Shermans support Marine and Army infantry in brutal close-quarters fighting. The tanks provide crucial direct fire support against Japanese bunkers and pillboxes, engaging targets sometimes at ranges of less than 50 yards. Sherman flamethrower variants, nicknamed Zippos, are particularly effective at clearing cave complexes and fortified positions. The tank's reliable engine and transmission prove vital in the heat and humidity of the Pacific, where many vehicles simply break down under the strain. In the Philippines, Shermans support the liberation of Manila in street fighting that rivals anything seen in Europe. In Okinawa, they provide mobile firepower during the 3-month battle for the island, helping to break the Japanese defensive lines. When Japan surrenders in August of 1945, Shermans are being staged in the Pacific by the thousands in preparation for the planned invasion of the Japanese home islands. The invasion that never comes. The Second World War ends with the Sherman as the most numerous tank in Western Allied service. It has fought on every front, in every theatre, under every conceivable condition. It has served with American, British, Canadian, French, Polish, Soviet, Chinese, and numerous other armies. It has been produced in greater numbers than any other Allied tank. And critically, it has done its job. Not perfectly, not without cost, but effectively enough to help win the war. In the decades following the war, the Sherman's reputation undergoes a strange transformation. Military historians, particularly American ones, focus on the tank's tactical shortcomings. They emphasize the losses, the disadvantages in one-on-one combat against German armor, the vulnerability to enemy fire. Books and documentaries portray the Sherman as a death trap, its crews as sacrificial lambs sent against superior German machines. The myth of the under-equipped American tanker facing impossible odds becomes part of the popular narrative of the war. This narrative is not entirely wrong. American tank crews did face better-armed German tanks. They did suffer casualties that, in individual engagements, were often lopsided. But this narrative misses the larger strategic picture. It judges the Sherman by the wrong criteria, evaluating it as if it were meant to be a dueling weapon rather than what it actually was, a component in a massive, integrated system of industrial warfare. Consider what Germany needed from its tanks. Germany, operating from a position of resource scarcity, needed tanks that could achieve tactical victories against superior numbers. Every German tank had to be a force multiplier, capable of destroying multiple enemy vehicles in each engagement, because Germany could not replace its losses as quickly as its enemies. This drove German design philosophy toward heavier armor, bigger guns, more complex engineering. The Tiger and Panther were optimized for tactical excellence because Germany needed tactical excellence to compensate for strategic weakness. Now consider what America needed. America, operating from a position of resource abundance, needed tanks that could be produced rapidly, shipped globally, maintained in the field, and replaced quickly when lost. America needed a tank that good crews could use effectively, and that average crews could at least operate competently. America needed a tank that would still be running after 3,000 miles of road marches. America needed a tank that could be modified and upgraded without retooling entire factories. The Sherman was optimized for strategic sustainability because America was fighting a global war across 2 oceans against multiple enemies simultaneously. By these criteria, the Sherman was not just adequate, it was nearly ideal. Its reliability was legendary. Units equipped with Shermans reported operational readiness rates of 70 to 80%, meaning that at any given time, the vast majority of their tanks were ready for combat. German units were fortunate to maintain 50% operational readiness with their more complex tanks. Soviet T-34 seconds, despite their rugged design, often had operational rates below 60% due to poor quality control in wartime production. The Sherman's ease of maintenance meant that minor repairs could be handled by crew members with basic training. Major repairs could be completed by battalion-level maintenance units without returning tanks to rear area depots. This kept more tanks in action more of the time. German tanks, with their complex transmissions and temperamental engines, often required specialist technicians and depot-level facilities for repairs that a Sherman crew could handle with a toolkit and a manual. The Sherman's comfort, often dismissed as a frivolous concern, actually mattered significantly for crew effectiveness. German tanks were cramped, poorly ventilated, and exhausting to operate for extended periods. A German tank crew might be physically and mentally spent after a few hours of operations. The Sherman, with its relatively spacious interior, powered turret traverse, and better ventilation, allowed crews to remain effective for longer periods. In a war of attrition where the side that can maintain operational tempo longer often wins, this seemingly minor advantage compounded over time. The Sherman's simplicity also made it an effective platform for Allied forces with less sophisticated logistics and training pipelines. British crews praised the Sherman's reliability compared to their own domestically produced tanks. Soviet crews, when equipped with Shermans through Lend-Lease, appreciated the tank's ease of operation even if they often preferred the T-34's firepower. Free French forces rebuilt their armoured divisions around the Sherman. Polish units fighting in Italy relied on Shermans. The tank's user-friendly design made it possible to equip and train Allied forces quickly, multiplying Allied combat power in ways that more complex vehicles never could have. After the Second World War ends, the Sherman's service continues. When North Korea invades South Korea in June of 1950, the first American armor to respond includes Sherman tanks from occupation duty in Japan. These Shermans, by now 5 to 10 years old, face Soviet-supplied North Korean T-3-485 tanks in the first tank versus tank battles of the Cold War. The fighting reveals that the Sherman, when equipped with the later 76mm gun, can hold its own against the T-34. More importantly, the Sherman's reliability proves crucial in the mobile warfare that characterizes the early months of the Korean conflict. The Sherman continues serving in armies around the world for decades after World War II. Israel uses Shermans extensively in its War of Independence in 1948, and continues using upgraded versions through the Six-Day War in 1967. The Israelis fit Shermans with modern French and British guns, demonstrating the tank's adaptability to upgrades. Some of these modified Shermans, nearly 30 years old by the time of the Six-Day War, still prove effective in combat. South American nations operate Shermans into the 1980s. The tank serves with armies in Asia, Africa, and the Middle East. Some Shermans are converted into armored personnel carriers, recovery vehicles, or engineering equipment. A design intended for a specific war in the early 1940s remains militarily relevant for nearly 50 years. This longevity is itself a testament to the fundamental soundness of the design. Modern historians have begun to reassess the Sherman with a more nuanced understanding of its role and purpose. The focus has shifted from comparing individual technical specifications to examining the tank as part of a broader military system. Viewed through this lens, the Sherman emerges not as a failed attempt to match German technical superiority, but as a brilliantly executed answer to the actual requirements of coalition warfare on a global scale. The Sherman succeeded because it was designed for success in the real world rather than in theoretical combat. It prioritized availability over invincibility, knowing that the tank that is in the repair shop is worth less than the slightly inferior tank that is still fighting. It prioritized manufacturability over perfection, understanding that 10 good tanks defeat 3 excellent tanks. It prioritized operational sustainability over tactical dominance, recognizing that wars are won by armies that can stay in the field, not by armies that win individual battles, but cannot replace their losses. This is perhaps the hardest lesson for military planners to learn, then and now. The temptation to pursue technical excellence, to build the best individual weapon system, is always powerful. The Germans pursued this path in World War II and built tanks that were, in many respects, technically superior to anything their enemies fielded. They also lost the war, in part because their technically superior tanks could not be produced in sufficient numbers, could not be maintained in field conditions, and could not be replaced when lost. The Americans took a different path. They built a tank that was good enough, and then they built it in such quantities that good enough became overwhelming. They created not just a weapon, but an entire industrial and logistical system designed to support that weapon in combat across the globe. They demonstrated that in modern industrial warfare, sustainability and availability can trump individual technical superiority. Standing here in the 21st century, we can see Sherman tanks in museums and memorials around the world. We can read the accounts of the men who fought in them, who cursed their limitations and mourned their losses, but who also acknowledged their reliability and appreciated their strengths. We can examine the statistics, the production numbers, the operational readiness rates, the combat records. And we can understand that the German tank commanders who laughed at the Sherman in those early encounters had fundamentally misunderstood the nature of the war they were fighting. They saw individual tanks and judged individual capabilities. They failed to see the industrial and logistical machine that those tanks represented. They won battles and lost the war. The Sherman, derided and dismissed by German crews who destroyed them in combat, nevertheless rolled across Europe in numbers that could not be stopped, could not be outlasted, and ultimately could not be defeated. The Germans built better tanks. America built enough tanks. In the arithmetic of total war, enough proved to be the same thing as victory. The legacy of the M4 Sherman is not the legacy of technical brilliance or tactical dominance. It is the legacy of industrial might harnessed to strategic purpose. It is the legacy of practical engineering solving real-world problems. It is the legacy of a weapon system designed not for glory but for effectiveness, not for individual superiority but for collective victory. 50,000 Sherman tanks did not win World War II alone, but they were an essential component of the victory. They were the steel tide that no enemy could turn back, the endless reserve that no amount of tactical skill could overcome. They were, in the end, exactly what America needed them to be. They were enough.